Wait, man, no. This ain't right. Who turned my neat chemistry lab into this chemistry crime scene?
It's what's happening here. All of this place look like one big mixtures of mixtures.
3 minutes. I left for 3 minutes to get filtering paper, and this is the disaster we come back to?
Wait. I see a clue. Solve the science, restore the lab, identify mixtures and underclone compounds.
Then we accept the challenge. Team, gear up. We solving this mystery scientifically. Good evening, everyone. My name is Apollo Sevenish, and I am the lead investigator for the lab.
Good evening, everyone. I am Natalie Jordan, the chief researcher for the science catastrophe.
Hi everyone, I'm Keturah Smith and I am the evidence analyst. Good evening everyone, I am Brianna Thomas, the lab technician.
So, since the lab is in a crime scene disaster, let's find the clues and figure out what are compounds and what are mixtures. I will hand you over to Dr. Nick, who will tell you what are the mixtures and what are the compounds. Dr. Nick?
Hi, I'm Dr. Nick. You guys are probably wondering what a mixture is. So a mixture is a combination of two or more substances that are physically combined and not chemically bonded. Some characteristics of mixtures are: substances keep their original properties, no new substance are formed, no fixed ratio, it can be separated using physical methods, it does not have a chemical formula, and it can be homogeneous or heterogeneous. So some examples of mixtures are salt water, coffee, which is homogeneous, and sand plus water or oil plus water is heterogeneous.
So what you're telling me, mixtures are when you combine not one, not three, not four, but two substances together. So it can be like sand plus sugar.
Exactly.
All right, I catch you then. I catch you.
Since we know what mixtures are, what is compound?
A compound is a pure substance formed when two or more elements chemically bond in a fixed ratio. Some characteristics of compounds are: elements are chemically bonded, new substance with new properties formed, fixed composition, represented by chemical formula H2O, CO2. It can only be separated by chemical reactions. It always uniform, pure substances, and some examples of compounds are ionic and covalent.
So the big question is, what in this lab are compounds and what are mixtures? So let me tell you, we're going to find out because it's experiment time. Good afternoon, everyone. It's experiment time. As you guys know, our lab is in disarray. We're right now in a chemical disaster. We have so many compounds and mixtures and solutions all combined together, and it's our job to separate them. Now, the first thing we're going to separate is by the means of filtration. So today our lab is going to be focusing on the separation of mixtures by means of filtration. Now, the things we're going to be separating will be sand and water. So our aim is to separate a soluble, being water, from an insoluble, being sand. Now, For us to adequately conduct this experiment, we have to have some materials here to help us. We have our filtering paper, our beaker, our funnel, our retard stand, our storing rod, but today we're going to be using a spatula. Obviously, our insoluble, the sand, and our soluble, the water. Now, as you can see, we have our lab set up here to separate our mixture. First thing we're going to do is combine our soluble to our insoluble. Now, we're going to give it a stir. As you can see, our soluble and insoluble did not mix together, but we still need to separate them. After we've gotten our mixture, we're then going to take our filtering paper, fold it in half, half again, and open it like this. And we're going to place it inside of our funnel. Good. So you're going to place our filtering paper into our funnel, which is attached to our retard stand. Our next step is to take our mixture and place it or throw it into our filtering paper. And our filtering paper will begin to separate the insoluble from the soluble. Now, as this process continues, we're going to take a step back and wait and come back, and we're going to tell you our observation. So, as our solution filters, I'm going to be telling you a bit about ionic and covalent compounds. Now, you might be wondering, what are ionic bonds? Now, an ionic bond forms when one atom transfers electrons to another atom. This usually happens between a metal and a non-metal. Some characteristics include electrons are transferred, it forms a positive and negative ion, atoms attract because they oppose charges, and they usually form crystalline solids like salts. Now, some examples of ionic compounds include sodium chloride, which are table salts, magnesium oxide, and potassium bromide. Now, we're going to be talking about covalent bonds. Now, a covalent bond forms when two atoms share electrons. This usually happens between two nonmetals. The characteristics include electrons are shared, not transferred. It forms molecules, and it can form single, double, and even triple bonds. Now, some examples of covalent compounds are water, which means oxygen shares with two hydrogen ions, carbon dioxide, and oxygen gas. So we've looked at ionic compounds, we've looked at covalent compounds. Now we're going to do some comparison between the both. Now, the features we're going to be looking at, the first one includes electron movements. Now, for ionic compounds, they are transferred as opposed to covalent, which are shared. The types of atoms for ionic are metals and nonmetals, and for covalent are nonmetals and nonmetals. An ionic compound forms ions, while covalent compound forms molecules. Some examples are sodium chloride for ionic compounds, and for covalent are water. Now, the attraction for ionic compounds, opposites would attract, right? Or opposite charges. And for covalent, they share electrons. The state for ionic are solids, and for covalent are solid, liquids, and gas. Now, we've compared ionic compounds, we've compared covalent compounds, we've looked at water mixtures, we've looked at water compounds, we've even done experiments to show how to separate mixtures or solutions that are combined. Now, lastly, we're going to look at the comparison of mixtures and compounds. Now, the feature we're going to first look at is how these mixtures or compounds are formed. Now, for mixtures, they are physically combined, while compounds are chemically bonded. The ratio is that mixtures has no fixed ratio. You can add how much of each solution you want and they will still combine. But for compounds, it's a fixed ratio, a certain amount to a certain amount. For mixtures, no new substance are formed, while for compound, new substances are formed. For the separation methods, we use physical methods to separate mixtures, like filtration, and we use chemical methods to separate compounds, such as vinegar and baking soda. The properties is for mixtures, each substance keeps its own, while for compound, they have new properties. Formula, there are no formulas for mixtures, while compound has chemical formulas. Now, the types of mixtures are homogeneous and heterogeneous, and the types of compounds are ionic and covalent. So we're back after that short information break, and as you can see, our mixture has been fully separated. Now, some little things you would have observed during this experiment. Before filtration, the water or the mixture had a cloudy color because of the sand and water. And after filtration, as you can see, we have clean and clear water, right? When we mixed, we had the solid mixed with water, or the insoluble mixed with the soluble, and now we have the soluble or the solid, being the sand, collected in the filter paper, and we have the insoluble that is resting in the beaker. For this experiment, we're going to be observing the reaction of vinegar and baking soda. Now, we know that for compounds, we use a fixed ratio of each. Now, for today's experiment, we're going to be using 50 milliliters of vinegar and 5 grams of baking soda. To measure that, use a scale. Now, our first step is going to be taking our vinegar and placing it into our beaker. Nice and slow, nice and slow. After that, we're going to slowly pour our baking soda into the vinegar and mix. As you can see, a chemical reaction has already started. It began to bubble, form fizz, and slowly but surely, it's also going to change in temperature. So we're just going to mix it for a few, and then we're going to come back to you with our observations. So you can see all of that reaction that was happening earlier, the fizzling, the bubbling, it's all died down. Now, you saw the reaction between baking soda and vinegar. Now, the compound we got from that would have been sodium acetate, water, and a certain gas, which is dioxide gas. We're going to reobserve the reaction between vinegar and baking soda, but with a different ratio, because remember, compounds has a fixed ratio, and depending on that ratio, it also dictates how the reaction will go. Now, for this ratio, we're going to use 75 milliliters of vinegar, and we're going to use 3 grams of baking soda. Now, as you could see, with the difference in ratio, the reaction was different. With our first reaction, we used a ratio of 50 milliliters of vinegar and 5 grams of baking soda. And with that, our bubbling and fizzling did not reach that height. But with this ratio of 75 milliliters to 3 grams of baking soda, the reaction was more spontaneous. It rised up and it came out of the beaker. And as you could see, even after a few minutes, we still see the foam from the reaction here, right? And to the bottom, we have the settlement of the compound.
We separated mixtures.
We identify compounds.
We analyzed separating techniques and solved the clues.
So the question is, who caused all this mess?
Wait, man, every mess starts with something. Mixtures, compounds, reaction.
The mess was a lesson.
The culprit was science itself. Today, we learned the differences between mixtures and compounds.
Today, we use experiments to uncover clues.
We separated mixtures using filtration and evaporation.
Compounds using chemical reactions.
Case closed.